Welcome to today's tutorial on implementing advanced TypeScript utility types for dynamic data transformations in React applications. Imagine building a highly interactive web app where data structures evolve based on user interactions. Sounds challenging? Well, not if you harness the power of TypeScript utility types. In this video, you'll learn how to leverage these tools to write more flexible and robust React applications. Whether you're building dynamic forms or transforming API responses, understanding these concepts can dramatically improve your development workflow. So, if you're aiming to build scalable and maintainable applications, this tutorial is for you. And remember, for more insightful content and to stay updated on the latest in software development, hit that subscribe button and ring the bell for notifications. Let's dive into the theory behind TypeScript utility types and their significance in React. TypeScript is a statically typed superset of JavaScript that introduces optional static typing, which is invaluable for catching errors early in the development process. When used with React, it ensures safer and more predictable code. Now, utility types in TypeScript, such as partial, required, readonly, pick, and omit, allow you to transform and compose new types from existing ones. This capability is crucial for handling complex data transformations and minimizing redundancy in your code. For instance, with partial, you can make all properties of a type optional, which is useful when dealing with incomplete data structures. These utility types not only enhance type safety, but also simplify the code base, making it easier to maintain and scale your applications. By understanding and applying these concepts, you'll be able to manage data transformations dynamically and efficiently in your React projects. To see these utility types in action, let's look at a practical example involving a dynamic form in a React component. In our dynamic form.tsx file, we define an interface, form data, with properties for name, age, and email. We then create a partial form data type using the partial utility type, which makes all properties optional. This is particularly useful in form handling, where not all fields may be initially filled. Inside the component, we manage the state with useState and update the form data based on user inputs. Here's how it looks in code. Now, let's see our application in action. When you load the page, you'll be presented with a form where you can input your name, age, and email. As you type, the data dynamically updates, leveraging TypeScript's partial utility type for flexible data handling. Switch to the API data transformation feature, and you'll notice how API responses are seamlessly transformed to exclude sensitive information like passwords. This transformation is powered by the Omit utility type, ensuring only the necessary data is exposed to the user. These dynamic interactions showcase the practical applications of utility types in real-world scenarios, enhancing your application's robustness and efficiency. To wrap up, we've delved into the world of advanced TypeScript utility types and their role in dynamic data transformations within React applications. By mastering these concepts, you're not only improving your coding skills, but also paving the way for more maintainable and scalable applications. As you continue exploring TypeScript and React, remember to experiment with different utility types and observe how they can simplify complex data transformations. If you found this tutorial helpful, subscribe to our channel for more hands-on tutorials and insights into modern web development. Your journey to becoming a TypeScript and React expert is just beginning, and we're here to support you every step of the way. Until next time, keep coding and keep innovating.